Hi everyone, this is Hossein from EJ Academy. In this video, I wanted to show you how you can use one of the libraries in Python to solve integral and use it towards your advantage solving your calculus problems. So previously in the previous video, we went over solving a problem related to calculating a volume of a solid. And so you can see the problem statement here. I put a link to that video here for those who want to watch that video. But basically, the problem asks us to find the volume of this shape here. And the information was given was the shape of the base of this volume, which was a parabola the area confined by a parabola and x-axis, as you can see here. This is the base of this volume, and the cross sections perpendicular to the xy plane as isosceles triangles. So this blue line here shows the cross section perpendicular to the x-axis, and on the right side you're looking at the cross sections, which is in YZ plane. So in this video, I want to show you how you can calculate that integral using Python. Python is one of the programming language which is widely used in by different programmers. So these days it is mostly used for doing data analysis and machine learning and AI. And so I found a library which is cool. It's really helped towards helping calculus problem. So that library is within Python. It's called Sympy, and I put the link to this page under this video. This library can help you solve mathematics problems symbolically, as it says here. So you can review this page. There are tutorials help you how to install the library, how to use it. There are examples, so you can go through that. So in this video, I wanted to specifically use this library to solve the problem that basically we went over that problem in one of our previous videos. So I'm going to write the code in Google Colab. So you can find that by searching Google Colab. I put the link also in the description below this video. So when you search it, so here you see Google Colab, and if you click on that, the third link, so it goes to the Google Colab page, and then you click on new notebook. So it's basically a notebook, and then you can write a code in that notebook. Okay, so there are two types of cells which you write the code in those cells. One are the code cells, the other one is text cells. Text cells are like this one that I just have text, there is no code in there, and then the code cells are the cells that you write a code, and on the left side you see this little circle with a triangle that if you click on it, it's going to run your code. So this is going to be saved in your Google Drive library. And so I have already created a new notebook, and you see the problem statement here. This is created in a text cell. Now under this text cell, I have an empty code cell, so I'm going to write the code here. So first I need to import, so this is an IDE, which is basically means an environment that you can type your code, edit your code. So I'm going to write my code here, and the code, they're running in Python. So this is one of the Python libraries. I'm going to import this library, and the command to do that is import, oops, import, and then the name of the library, Sympy. Actually, I'm going to import all the functions within that library. So from Sympy import all, the asterisk means, I want all the functionalities of the Sympy library. And then to run this code, I need to click on this triangle. It takes a moment to run the code. Okay, now we have imported all the all the functions of the Sympy library. Now I'm going to click on the code cell, click on the code to create a new code cell. So in that new code cell, first I'm going to define my variables. The variables, basically, because this is a symbolic, this is going to solve our math problems symbolically. I need to tell the code what are my symbols. So I'm going to use, obviously I'm going to have X and Y. So I'm going to have X comma Y comma, I can define all the symbols in separate lines, or I can combine them into one line and I separate them by commas. And then in addition to X and Y, I have B and H based on height of the triangle. So I have B and H, and then I have capital A for the area and capital V for the volume. So A and V. And then on the other side of the equal sign, I'm going to assign symbols to that. So symbols, see, Google Colab tries to help me. So I'm going to, inside the parentheses, I'm going to introduce all the symbols. I'm going to use the same name as the variables. You can use, different symbols for each variable. I'm going to use the same to avoid confusion. So X, Y, so there is a space between each letter. So X space, Y space, B space, H space, capital A space, capital V. So you don't need to put comma, in between all these letters. And then I can also, instead of doing it like this, I can also, do it line by one, like saying X equal symbols X, and then go to another line and say Y equal symbols Y, and so on. But so I decided to combine and then, save some time and then, put all these, define all these symbols in one line. And then I'm going to run that. And so after that, I'm going to basically, go into the mathematical problem that we have. So I'm going to add a new code cell, and then I'm going to say, so we know that y is equal 1 minus x squared. So I'm going to say y is equal to 1 minus x. And then a square in Python is with 2 asterisks. So this is y equal 1 minus x squared. And to make sure that, I have it defined properly, so I'm going to export it, or basically print it on the screen so I can see that. So I'm going to run this. So as you see, so I asked this software to give me the value of y, and y is equal 1 minus x squared, which is correct. Now I'm going to, in a new code cell, I'm going to define B and H. So B is equal to, so B is the base of the triangle is equal to 1 minus x squared. So B is equal to y. And then because y is equal to 1 minus x squared, if I if I basically export or print b, so the software tells me b is equal 1 minus x squared. I can do all this definition in one code cell, but I wanted to do it separately just to, make sure that everything is defined correctly and, also explain it to you step by step. So another variable we wanted to define is h, and we know h is equal to b. So can you guess if we print h, what we're going to see? So think about it. H is equal to b, and then if you move back, so we know that b is equal to y, and we know y is equal to 1 minus x squared. So if we print this, h is equal to 1 minus x squared, which is correct. So I'm going to add another code cell. At this time, I'm going to define the area. Area is a is equal to area. We're talking about the area of this triangle, which is 1/2 of the base times the height. So area is base times height divided by 2. And then if I print it, I'm going to see 1 minus x squared divided by 2. And the reason is that b and h are both 1 minus x squared. So when you multiply, it's going to you're going to get 1 minus x squared and then divided by 2. Now we're ready to do the integration, because if you remember from that video, so this area is the area of one of these triangles, and we have so many of these triangles from -1 to +1, and then we're going to add all those areas to get the volume of this shape. So I'm going to insert a new code cell, and then this time I'm going to define the volume. The volume is going to be calculated using integration. So I'm going to use integrate function, and inside I'm going to basically tell the one of the input is the area that I wanted to integral, use that area to use a to do the integration, and then I have a comma, and after that I'm going to tell the software what is the variable, which is x in this case, and then what are the lower limit and upper limits of the integral, which is -1 to +1. And when I run this, let me print v. Voila. This v is equal to be 8 over 15, which is the same answer that we got in our previous video when we solved this by hand. If I don't put any limits, so it's going to look like this. If I wanted to do indeterminate integral, I have to change it to this. I have to change, tell the, this function that I'm going to do integration using a, and x is my variable. And then when I run it, it's not going to give me a number. It's going to give me the result of that integral, which is x to the 5th divided by 10 minus x cubed divided by 3 plus x divided by 2. This is the same answer that we got in our previous video. Remember, in the previous video, we did the integral from, because it was a symmetric volume, we did the integral from 0 to +1, and then we had a multiplier of 2 outside the integral. So the answer of the integral in that video should be half of the answer that we got here. So let me put this back, put the limits back into the integral, and then run it again. So 815 is the answer. So to recap, here we use one of the Python's library that does symbolic math for us. So we import the library, we define our symbols or variables, and then we just define all these variables, and at the end we define the area and we define the volume using the integrate function. If you have any questions related to this video, you can leave your questions below this video in the comment section. And if you haven't subscribed to our channel, please subscribe to our channel and support our channel. And if you like this video, if this video was helpful, please hit the like button. And until next video, bye everyone.